I'm Vlade Lisboa. I work for GeoCue in Brazil. I'm a regional sales manager for Latin America. And I'm basically here to show you some successful case from a customer that we have in Brazil that work with Forestry. It's Bracell. Bracell is one of the biggest cellulose company in the world. So they are based in São Paulo, actually in the countryside of São Paulo. And we have been working with them since a while, supplying our LiDAR solution, of course. They are using one of our sensors that I'm going to show you a bit later on the slides, and of course the LP360. So they are helping us a lot to implement things, especially using the ITS solution that we have. So basically what I'm going to show you, if that works, let me see. So this is basically the steps that we have talking about forestry on the cellulose world, of course. So first one is basically the planting, right? So we have the planting first. Actually, the first one is the land preparation. So they also using LiDAR for land preparation. I'm going to show you the next slides. And then, of course, cultivating and harvesting. So all these steps, they are somehow using the LiDAR solution for it, right now. On land preparation, of course, this is basically the way to prepare the terrain for the planting. So what we do with LiDAR is basically DSM, DTM, the ground contours and the ground elevation. So for that, they are using LiDAR for everything, right? And then for planting, they are using basically two technologies. The first one, when they have like 30 to 60 days of the planting, they are using the multispectral solution, the multispectral camera, to see the seed numbers, the seed position, and the survival rate. And after that, after 6 days and more, they started using the LiDAR and with the ITS solution for doing the tree number, the tree position, the high and the grow area. So this is basically the two steps that they are doing on this part of planting and cultivation. Inventory, of course, this is one of the most important things that they were evaluating and testing and using the ITS for that, to see that, of course, the tree numbers, the tree position, the height and grow area. And then, right now, they are in process to try and testing the wood pile volume, also using the LiDAR, the pulp stockpile volume, and probably the biomass residue detection, biomass residue elevation, and biomass residue quantification. So this is basically the entire workflow that you want to use, not just using a LiDAR, but everything that they can't. But the LiDAR would be one of the most important solutions from them right now, right? So, so the workflow is pretty simple. Actually, what we are doing right now, they actually are using one of our sensors, that is TrueView 535. By the way, who has some kind of TrueView sensor over here? And 535, some of them have three. Okay, so they are using the same sensor as yours. But they also have a couple of L1s from DJI, so they are basically using both. Of course, with the DJI L1, they have some kind of issues, especially in terms of penetration power, because of course the footprint of the sensor is a bit higher than comparing with the 535, right? But they are still using the L1s for that. So in LP360, they basically use it to create trajectories, strip adjustment, fast ortho mapping. I think all of you have seen that before on the LP360. And of course the classifications, the DSM, DTM, counters, ITS, ortho, volumetric reports, and vegetation class. So this this is basically the entire workflow. And of course, from here, they export the final results to different departments, like engineering departments, so cultivating departments, so harvest departments, depends on which kind of information they are trying to get. The reason of course, the 535 is a little better than comparing with L1, it's because of this laser footprint. I think most of you have seen this kind of information before, but if not, this is basically the size of the point that comes from the sensor through the ground, right? Of course, as smaller as this point, as vast is your penetration, right? So that's the reason that if you compare different sensors with different laser power, you can see different results, right? So for example, on 535 and 515, you have like 22 centimeters comparing with the other one. It's very slow, it's very smaller, right? And the Regal system is it's smaller, so it's like 16 centimeters. This is the flight that's 100 meters flying. And we have a new sensor, this is TrueView 540, that you can see the footprint is really amazing. So this is one of the other sensors that we really indicate for this kind of job, right? So this is a really, really nice sensor. It's make a lot of success in Brazil as well, in Latin America. This is a bit what we have on TrueView 535 for the one that use it. So it has basically a HISA sensor. It's up under M2X. We can fly at 120 meters. That's what we suggest to the customers. We have APX. How can I find that here? So we have an APX, the IMU that we have, it's a Trimble APX 15, 128 gigabytes of internal storage. That's good because we have the internal storage and we have a pen drive that we can connect to the system. So the workflow here is pretty fast. So you don't need to connect any cable from the sensor to the computer, you just remove the USB drive, put it on the computer and start working with it. This was good for Bracell because just for you to have an idea, in 1 month, almost 1 month and a half, they've collected like 3,000 hectares of area. So they are flying mostly every day, doing a lot of different areas, different places with a really good amount of data, right? And here we have one of the most important things on our sensors. Of course, are the cameras. So on this case of 535, we have like 3 cameras. So we have 2 oblique cameras here on top, and 1 laser camera here. All of them, they are on 26 megabytes per each. But most of the people ask me why you have more than 1 camera on your system. This is basically for us to get a better field of view, or a bigger field of view, right? So if you see here, we have the laser fob that you can, of course, set that on the LP360, right? And we have the camera fob. So with the 535, we can easily go until 9 degrees, and we can actually go up to more than 100 degrees on it. And we have also the overlap region. So the important thing to have the overlap region is that on the same flight, using a smaller overlap, you can get 2 results. You can have a nice LiDAR results, and you can also have a very nice camera result as well. You can use that for creating an orthophoto, for example. So you don't need to worry about, oh, let me try and overlap like 80% or 90%. So we can work, for example, on 40% or 50%. That's basically going to be very good for LiDAR. And at some point, you can use that flight to create a nice orthophoto. What is the impact of that? The impact of that is, of course, productivity. So you have much more productivity with that. So you don't need to do a second flight with another drone for photogrammetry, you don't need to worry about to have a very huge overlap. So you can work just with LiDAR, and then you're going to work with photogrammetry as well. And just for you to have an idea, flying with the TrueView 535 at 80 meters, we are going to have a kind of swath of 160 meters. So this is a very nice productivity numbers, right? So if I go here, I think most of you, let me change my microphone. So if you go here on this Excel, you can see here the productivity that we have here with the 535. This, by the way, is Excel that we supplied when you are doing training. I think most of you have seen this kind of Excel before. If not, it's very useful to not just to create the flight lines or the flight planning, but also to have which kind of results and which kind of area volume that we can get flying with our sensors, right? So just to give you an example, flying at 80 meters at, let's say, 7 meters per second. Actually, for Forestry, we recommend something around 5 meters per second. We're going to have better results. Of course, it depends on the date of your Forestry. But after, let's say, 1 year, 2 years, or 3 years, that the trees are very high, recommended something around 5 meters per second. But let's leave it in 7 for now. The field of view, we can work, the recommended is 80, but as I said, you can go through 90 until 100, more than 100 actually. But let's stay here, let's put 80. This is the recommended one. The overlap position, I would use like 40. And here, if you go on the right side, of course, here you can also see the density of data, so how much points per square meter you're going to have using the settings. If you are doing a cross-section, I mean a cross-flight, you can see that we're going to have the double of numbers here. Or if I'm flying with 50% here, that means we are going to duplicate the amount of points that I have on the data set. But for them, the most important part as well is this side here. So in the flight of between 20 and 25 minutes, that's basically what we have flying with Matrix DJI M300. This is the aircraft that they have, the drone that they have. So you can see that in, let's say, in 25 minutes, we're going to have like 80 hectares per flight. So that's pretty good. So just to show you an idea, if I needed to do, if I just have, let's say, one camera, and I want to do the same flight to getting the orthophoto as well, I will probably need to change the overlap for, let's say, 80. So you can see that the productivity is much smaller right now, because I'm just, leaving the flight lines much closer. So you have a less productivity on that. So that's the reason that you're using a system with, in this case, 3 cameras or 2 cameras. You're going to have a much more productivity on that, right? So let me go back. This is another good feature that we have on 535. That's basically, it's a sensor. The under his side is a 32 channels laser. So with that, we get like 20 degrees forward and backward on the flight. So as you can see here, I'm going to have this kind of details when I'm scanning. So if I have just a nadir scanner like this one, I will probably miss this part of the data. So for forest, this is an important thing because I can scan the trees at different angles, right? So you can see that to create different results on the LP360. So this is really makes some difference when we're working with this kind of solutions. So you can see the difference between one and the other here. And of course, the 5040 is one of our new sensors that's we really recommend for this kind of jobs, this kind of application. It's a CHC nav laser. You have like 80 returns. one of the reasons that we like this sensor is because they have a huge range. So you can fly higher than comparing with 535 with the same results. Of course, we have the limitation of the law, right? So in Brazil, we cannot fly higher than 120 meters. I think it's the same as here. But on a place when you have different kind of terrain, so you don't need to worry about following the terrain always under 100 meters, for example. So you can use this kind of sensors to go like a linear flight, and you're going to have the same results. So again, your productivity will be much bigger than if you are just following the terrain with the other sensors, right? So you don't need to worry about it with the 540. Another difference is a camera. It uses just one camera, but it's a full frame camera. It's like you are flying with the LiDAR and a P1 together in the same system. So it's really good to increase and to have a very nice autophoto as well. The weight is almost the same as the 535. Accuracy is very good as well, between 2 and 5 centimeters. The scanner is another good one because it works with 500 kilohertz. Well, the TrueView 535 is 640, but 640 in 30-60 degrees, right? So here we're talking about nadir. So they have like 500 kilohertz, but to the ground. So the density of points here will be much bigger than the 535 in this case. So I'm going to show the software right now, but just to have an idea, the steps again. So the first step is to create from Bracell, is to create the DTM and DTSM. So this is the first thing that they are looking for. So the first step that they do on the software, let me try to go to the LP360 right now. Of course, I don't have a huge project from them, but I have a small part of a flight that they gave me. For security reasons, they are not supplying entire flight cycle for us, but we can at least see a part of this flight that they did. So of course, it's a huge place. Let me see if I have internet connection, so you can see that it's just a little part of the forest that they have on this spot, right? But the first thing that they do, as I mentioned, was the ground. So they basically use all the tools that we have here on LP360 for the ground. I think you have seen that, or if you are participating on the training, Kevin just showed, I think on the first day, how it works. So first thing they do is to create this ground, right? So then put here elevation and thing surface. So this is the first step that they're doing. So this is basically used for the land preparation. Can you hear me well? It's okay? Okay. So this is basically the first step that they do for the land preparation for the planting, right? So of course they also use the counters for that. And then after that, the workflow, they do like a ground pinning. I think we have mentioned that before on our training as well, how to do that. There's many ways to decrease the amount of points that we have on the ground here on LP360, because if I just put these LIS files into another engineering software, you're going to probably have some problems in terms of performance. So what they do a ground thinning to remove a little bit the amount of points that we have on the ground before exporting to, let's say, a Civil 3D or any other CAD solution that they have. So for that we have this option here, that's the ground thinning, right? So you can reduce the number of points per square meters before sending to the engineering software. So from here, because everything starts from this ground, right? Because if right now what we need to do is to do a kind of vegetation class. So we need to classification this kind of vegetation that we have in this area, and after that I'm going to use the ITS. But to use the ITS, I need to start from the ground as well. So that's a good point, because they start the ground to do the land preparation, and after that they're using this ground information to start to working with the ITS solution here on LP360. So the workflow keeps going very easily, very fast. So this is the first thing, again, that they do. Go back here to the slide. Is basically the planting. I don't have the images from this project over here, but you can potentially use the Image Explorer. I think most of you have seen the Image Explorer, how it works on LP360. So you just do a click on your point cloud, and you can see immediately all the images that you have around that point that you have selected, right? So that's very useful for them, because you can see the inspection. So you can see, for example, if one of the trees have some problems to growing, so you can see that using the image for that. So it's basically this information over here. So you do basically a click on your point cloud. I can show you another data set if you want to see it. But you just click on it, and then you can see all the images around this corner, right? So you can see all the images from that. And with them, we can use it for quality control, right? So you can use the Image Explorer to see if there is some failures around your planting, or if there is some trees that is not growing so good. So you can do a kind of quality control of your landing to see if you need to apply some other products or some other kind of cultivation on it. And monitoring. And here we start with the ITS, because you can see the canopy height model. You can see, of course, using the ITS, the volume, the amount of trees that I have on that specific area. So you can counting how many trees I have there. With that information, they can potentially export that to the engineering or to the harvesting department to see what they're going to have on that specific place. So going back here to LP360 right now. So once I have the ground, let me turn the contours off for a second, go back to all points. So once I have the ground, I can, of course, let me create here, let me try here, the profile, just for you to see the trees that I have on this place. So this is like 6 years old trees, so you can see that they are a little bit higher. It's something like 23, almost 24 meters, right? So if I go to the ITS algorithm over here, that's supposed to be in classification. So this is basically the numbers that have been used for this kind of forestry. So the first number is basically the crown diameter. So we need to actually three data from the data set. First one is this average crown diameter. So I can check that just using the profile window and using the measurement tool, and check here the space between the crown tree that we have. So with this information, I basically put here on the algorithm like this. The second one is the tree distance. So you basically use the information from here, and that's a good point to explain how the 32 channel works. So the 32 channel help us to get this kind of information, right? So the base of the trees, you can visually see it very good here on the profile window because of the 32 channels that we have on 535. We don't have that on the 540, but on 540 I have much more data because, as I said, it works with 500 kilohertz nadir to the ground, right? So you have much more points to work with. So you are going to see even more details when you are using with the 540 because of that, right? So with this kind of numbers between the trees, so I go back here on the tree segmentation algorithm and put it here. In this case, coincidentally, is the same. And then the number 3 high, I say another important info from them is the minimum size of the trees, because they are not concerned about the small trees on this part, right? So they have some kind of small trees here. It doesn't matter to them, so we can remove that info from the ITS. So you basically again can use the profile window to check that. to check the minimum tree size, tree height of that. So you can go back here and put this number over here, and then you can just run it. When you run it, it creates a new layer, right, with this information, and it also creates a shapefile, a layer with the shapefiles here. So if of course, it creates what we call extra byte information. So if I choose here now on my filters the extra byte info, and here I choose the trees, because I'm going to use the 3 points, the trees points. So you can see, let me close this for a second. You can see all the, I put here points, so you can see all the trees already classified, right? And of course, if I turn this layer on, I can see all the points and all the IDs per trees, right? So right now, and of course, it's not that useful, but if I go here and select show labels, you can see it. Each tree has a kind of ID, kind of number, right? So with that, if I go, you can obviously see that also on the profile window. So if I open here in the profile window, you can obviously see the same info here on the profile. That's pretty good to see the results, if the results are good or not, right? So they use this info a lot. And from here you can also, let me turn this off for a second, you can also see the results. If I go here to the feature analysis, you can see all the numbers that I have on this area, like for example the total of trees that I have, in this case is more than 3,000, almost 4,000, and the surface. So with the surface numbers that they can calculate it, the volumetric things from that area, right? It's not total precise yet. So what we are doing right now with them, when I go back to the slide, we're going to see it. We are starting to use the TrueView Go, the SLAM system that we have, to go through the trees, at least a part of the trees that we have, and then using that information to put on the volumetric things. So this is the next step that we're going to test with them right now. So, but with this information, they are already happy actually, because they have some kind of samples that they can use to calculate the volumetric things. But again, with this SLAM would be much more precise for that. We don't, of course, we are not going to use this SLAM for the entire area because it's huge, right? But what they do, they choose an area that it's very similar with the others, and then we can expand that info to the other. So that's the way that we are going to test it right now. So, and of course, this you can also export to an Excel. So you can easily export that info to be used in Excel in another departments of the company. And let me go back here again. So once that is done, of course, the next step would be using the TrueView Go, the SLAM, to calculate what we call dBH. That's basically the size of this part of the trees, right? So with this info, we can of course get more precise results in terms of volumetric things. And here again, right now we have this, right? So we have this information directly on LP360, and of course using this lab with the dBH, we are going to have the entire and most precise volume thing. And then the last part that we are right now doing some tests is the pulp volume, because we have the volumetric things inside of LP360 that's mostly used for mining. So I don't know if any of you work with mining, but in Brazil we have many customers already using it for volumetric things for mining. We have tested that with sugarcane as well. It works pretty good. And now we are starting testing this with Bracell as well, to calculate the pulp volume and the wood pile volume as well. I think that's it. I talked a little bit.